What is going on, everybody? Welcome to part 15, the final part to the Python 3 Basics series, and then you guys are getting kicked out. There are just a few more things I want to show you guys, so let's go ahead and get into it. So the first thing I want to talk about is packages with Python. So, the reason why Python is such a popular language and such a powerful language, yes, it's easy to write. Yes, it's fast to write. Yes, it's easy to read, all those things. But there are other languages that meet those criteria, like R and Julia and Ruby and other ones that I can't think of right off the top of my head. But there are lots of other high-level languages, like Python's high level because it's very far from the hardware level, as opposed to like C++ is a lower-level language, but still classified as kind of a high-level language. Anyways, there are lots of languages like Python, but why is Python the best? In my opinion, it has to do with the community around Python. And not just because we're all really good people and we're fun to hang out with. That's a joke. It's because of the third-party packages that are available with Python. That's what makes Python so powerful. Because actually what truly powers Python is C. So Python is really just kind of like, it's like this constant API/wrapper around an otherwise much faster language. So what makes Python the greatest is the packages. So the main thing I want to talk about here is using third-party packages with Python. So there's a bunch of different ways you're going to get third-party packages. The main way is with pip, which I'm going to show you, but I also want to talk about some of the other ways and what even is a package. So you just understand that these things are not magical or anything. So the first thing I'm going to do is bop into tutorials, and I'm going to copy testing grounds. We'll go into testing grounds as well. And I'm also going to edit testing grounds here to be example mod. So that's just example mod.py. Great. So the first thing I want to talk about is, I guess let's talk about one of the more basic ways you might install a package. So most of the time it'll be via pip. Sometimes it'll be a package that you can only find on GitHub, but you still want to install it. If the package comes with a setup.py file, you can just use the following. So we can go to our command prompt, and then using Python and whatever version you want, p.15 in our case, if it had it, you would, first of all, you'd need to be in the directory that has setup.py. But then you would just run p.15 setup.py install. That's it. So you would do that. If it had a build, you might also build, but it would be in instructions. Most of the time, it's just setup.py install. Very simple. So that's one way you would do it, but that's kind of a dying method now. That's one of the older ways you used to install packages. We don't really do it that much anymore, but sometimes there will be a thing on GitHub that doesn't have a Python package index thing for whatever reason, so you can use this. But let's also talk about what even is a package, or like what's a library, what's a thing we can import, because we have made these imports, but we don't maybe understand how that works. So the first thing I want to do is in example mod.py, let's just define do a thing. It's going to pass nothing, and for now we'll just have it print doing something really cool. And that's all our example mod is going to do, just a simple function just to give you an idea. So then now coming over, and keep in mind, example mod is in the same directory as our testing grounds is. So now coming into testing grounds, we can import example mod. Import example mod. And when you import something, it's going to look for it in three places. It's going to look locally. It's going to look in your standard library location. And then it's going to look in your third-party library location, which is it's in your Python installation, then lib, then site-packages. It should be in there. I might have that wrong. I'm pretty sure that's the path, though. Anyway, it's going to look in all those locations, and this is why it's really important to, because it looks locally, it's important to never name your script the name of the package you intend to use, because you'll wind up just importing the script that you're writing, and then you're going to get some weird attribute error. I see it all the time. This is probably the #1 error that people ask in comment sections on tutorials of mine. They're like, hey, I'm getting this weird error, and I'm like, you named your script the thing you're trying to import, and you're importing yourself. Stop it. So anyways, watch out for that. So import example mod. So this imports this script, right? So it's going to look when it goes to import any directory or file named example mod, not any file, it would just be a .py file. So we've imported example mod or a .pyc. Anyway, we've imported example mod. Let's go ahead and show how we might use it. So you could use example mod dot, what was it, do a thing? I think it was do a thing. Yeah. So we can run this and we can see, cool, it just did something really cool and we just imported it. The other thing you can do is import something from a file. So we could instead say from example mod import do a thing, and then we don't need example mod dot. We just use the function. Boom. Same thing again, pretty cool. Now the other thing we can do is we can do, let's just make a new function here, a second function, define do another thing, and print doing some other cool thing. Save that, import do a thing, and then what was it, do another thing. So then you could do a comma, do another thing. We can save that, and then let's copy this, come down here, paste, run it again, and you can see, okay, we've imported these two things from example mod. Now another thing that you can do is if you were going to import a lot of functions, you might use a wildcard like this. So this is just almost like a regular expression for everything, or a wildcard that just means all the things. So we can do that and we can run this. But this makes your code pretty hard to read, first of all, because as someone's reading your code and like if do a thing, they're curious what is do a thing, they're going to have to do some digging to figure out where the heck did that come from. Because like say, like in the case where we have only one import, the wildcard, okay, we know where that came from, probably. First though, we're going to have to comb through the entire script that, you know, maybe it's thousands of lines, see if this function has been defined in here, and then we'll have to go to the import and be like, oh, okay, it's an example mod somewhere, you know. But the worst thing would be like, what if you just continued using these wildcard imports? Like you know, inside of example mod, you've got some wildcard import. It just makes it really annoying to read someone's code that's used these. So my suggestion to you is don't do it, but sometimes people will do it. And so anyway, just know that's a thing. The other thing you can do is you can import a thing as a thing. So not only could we have imported example mod as a thing, we can also import do a thing as dat, short for do a thing. So then we can come down here and we can actually just run dat. We've basically kind of, you know, renamed the function, and we run that again. So that's pretty cool as well. Also, let's say you've got a lot of scripts in a thing that we would more likely call a package. Like in this case, it's just a single script that we're going to import. I wouldn't call that a library or a package. What you would call a package is like a cluster of scripts. So let's make a new folder, and I'm going to call it mod_dir. And then I'm going to take example mod here, and I'm just going to put it into mod_dir. So then you might also do something like this. So from mod_dir dot example mod import do a thing, print, or no, we don't have to print. We just run do a thing, boom. Okay, and so that's how you could have like a group of scripts inside of a directory and reference one of them specifically. Okay, I think that pretty much covers the extreme basics of what a module is. It's not that complex. In most cases, it's just a Python file. In some cases, it does get a little more complex because it's really a Python wrapper around C code. So it does get a little more challenging, and especially historically, it was very challenging to work with Windows in this way. But lately, all the C-wrapped packages that I've seen install very easily with what's called pip. Now pip stands for, pip installs packages. So it's one of those like recursive acronyms like PHP or something silly like that. And so the Python package index is what pip kind of communicates with. So here you can search for projects and stuff like that to figure out what you want to install, and then you really just install it with pip. Now, the thing to keep in mind, now that you've learned what a package actually is. It's just Python code. So remember, it's easy to forget. What are you doing when you install a package? Because it's as easy as going to your command line, and we did it with like NumPy in one of the videos, I think it was the last one, pip install NumPy. You just run that thing and you don't really think much about it. But the thing is, you're plausibly bringing in a lot of code, and then when you use NumPy, when you import NumPy, whatever's in like a main loop or not a main loop, but a main function to run, or when you initialize that thing that you've installed, you're plausibly running a lot of code. And it's in a way that a firewall is less likely to catch because it doesn't look as suspect as you running some crazy.exe file. So pay attention and think about what you're doing here, because when you're installing a package from pip, you are trusting someone else's code. You're just taking it, and unless you're reading every line, which I know you're not, like you have to understand what you're actually doing. And because of this, I would really watch out, because like for example, really recently, let's say Python package, oh my gosh, package index malicious. Just the other day, here we go, 6 days ago on this website, they're talking here about 6 packages they found to contain malicious code on the Python package index. Now it's hard to see this table, but if I zoom in, you'll see that, like for example, this is intending to mimic the package Django, for example, but you see they called it Django. So it's for people who accidentally typo. And it's the Django package plus some stuff. Okay? And you don't want it, all right? And at least in this case, what they were doing was anytime you entered like a Bitcoin address, it would just change it to a different Bitcoin address, whoever was doing this. And that's what that was doing. But it can do all kinds of malicious things, and so you just need to be careful. So, check and recheck the package name. Maybe go to the official package on the Python package index. I'm looking to see, I don't even know. Usually I don't even look here. It would be cool if they said how many installs were used. You also could look at their GitHub page. Like this one doesn't appear to, which is weird because I swear text wrap isn't that new. But like let's say we went to Django. We'll look at Django 2. Let's see if their stats are good. So here you can see, okay, on their GitHub, they've got quite a few. I don't know what it would look like before, but the other thing you could always do is go to their GitHub and just, confirm you got the package name right. Okay. Anyway, pay attention to that stuff. And then you can see here, all you have to do is use pip to install. So we're not going to use Django. In fact, I'm going to use Colorama, which was one of the infected packages. So it was typoed to be the European spelling, I guess, of color with the U, but the proper one is pip install Colorama, and so we can install it that way. Also, I'm just trying to get myself into the habit of always using the specific version, so py-37-m pip install Colorama, like so, and that will give us the Colorama package. Now, when you get a new package, let's just Google Colorama. There's a variety of ways that packages will document themselves, and no one's documentation is as good as everybody else's. So you just kind of or everyone's documentation is a little different. So some packages have unbelievably great documentation; it's really easy to use. Other packages don't. And then in terms of complexity, they all vary. Colorama is a pretty simple library, so their documentation is basically right here on this page. But certain things like Django will have either their own website, or there's a website called Read the Docs, and that's a pretty popular documentation website. And so it just kind of depends, but usually you can just go through the documentation and learn how to use the packages. So for example, I scroll on down here, and I basically just scroll, here's the main thing, I just scroll till I see some text that is code. So in this case, I can see, okay, so to use Colorama, okay, I need to initialize it, all right. Looks like on Windows, we need to run init. On the other platform, it doesn't matter. So this is just for cross-platform. Okay, now to get it to print colors, all I have to do is, apparently you do this, then you add to the string. So this is probably, it's building the string so using the plus here. So this 4.red probably corresponds to a bit of code that probably looks really complex to you. So for example, this ANSI sequence here, like this is probably more so what it actually looks like, what this will translate to, but this is, you know, a little more easy for us to type. So it looks like we could change the foreground, the background, style, and then we can reset everything. And one thing to note is, like, when you change colors, you have to change them back. So when you say for red, that means everything that comes after that is going to have a red foreground, so pay attention. Okay, so let's go ahead and let's first of all, it's like just use Colorama really quick in our testing grounds. And probably in Sublime, it's not going to work. So we'll write it in Sublime, but then we'll have to run it in the terminal most likely. So first of all, let's do, and in fact, let's just run the sample actually. So here is the sample, and notice the sample doesn't have init, so we'll have to add that. Let's just paste that in, comma init, and then init. Not emit, init. Okay, save. Let's run that. I don't think it's going to work. It doesn't, I don't think. No. So we definitely need to run it in the terminal. That's not really surprising. Where am I? Here we go. So here, pi-37 testing grounds.py. And you can see we got some red text, some green text, and then back to normal. And in fact, it's kind of weird. I am on a VM, so maybe that's why it looks so funky. But that looks pretty, that's like really ugly looking text. I don't know why. This is really crisp and clear, but that text was not. Let me go properties. It's already quite large. Let's go 72. I don't really want it that big. We'll go 36. Let's just try a different font. Hopefully that doesn't screw anything up, but we'll find out. Okay, whatever. So the next thing I want to do is let's add this now to our tic-tac-toe game, because this is all fine and dandy, but let's actually like change something in tic-tac-toe or actually use the package, because demos are always different than actually using it, or you just don't realize certain things, right? So what I want to do is bop into tutorial 14. I think I'll copy paste that, call this tutorial 15 now. Right click it, open up in Sublime. And I'm going to exit out of there. And let's go to the, actually first we need to bring in Colorama. So let's go to testing grounds, and we just want to import, well, really all of this. So copy, come over here, paste. Then what we want to do is go down to where we display the game board, which is here. Where do we print the row? Here. So this is where we're actually displaying the game board. And what we'd like to do now is make it pretty. So, okay. So rather than print count row, we still want to probably print count, but we want to modify the row a little bit. So what I'm going to do is I'm going to make a new variable, and I'm going to call it colored row, because we need to build the row string. So I'm going to say colored row, and for now it's going to be nothing. And then we want to iterate over each item in the row. So what is each item in the row going to be? Well, there's only three things. In this case, if it's a 3x3, it'll start off as all zeros, and then as players play, it's either going to be a 0, a 1, or a 2. So what we want to say is for item in row. Then what we want to say is if the item is equal to a 0, what do we want to do? Well, we're just going to say colored row plus equals, and in this case, we don't want anything. We just want an empty space. Now, it was going to be a space, a comma, the number, and then a space again. So I think, or space, let's see. Between each, I'm going to put 2 spaces for now. It might be an extra space. We'll figure that out in a moment. Then, if item, actually we should make this elif item double equals a 1, let's say colored row plus equals. And then in this case, how do we do it? Let's make ones a green. So we can make it would be 4.green plus the thing that we want it to be. So I'm going to copy this right here. I'm going to come over here, paste 4.green. And actually, I think it's all caps, green. And then 4.green plus the thing that we want in here. So in this case, I'm going to make that a space, the thing, and let's make player 1 X. While we're here making this happen, might as well do that. So X, and then a space on both sides because you got the space and the comma. So so we make that foreground green. Now, one thing to note is as we do this, this has now changed the foreground to be green. So then after this, if it's a 0, notice how we didn't do anything. So we could either, reset at this point, or we need to reset after every, colored letter. So I think I'm actually going to reset it after the letter. So I'm going to say plus style.reset_all. And this will get us back to, whatever the default color is. And then we want to do the exact same thing, except for number 2. So then I'm going to come down here, elif, it's a 2. And then here, we'll do magenta, and it's going to be an O. All right, so then, rather than print row and count up here, let me just cut this. And then we'll come down here, tab, back to, okay, now print count, sure, whatever. And then, oops, colored row. So now we'll get the beautiful, beautiful colored rows. Hopefully, let's see what happens. So we come up into our console now. And let's pi-3.7. I'm so used to typing 3.6. Tutorial 15.py. Let's do a 3x3. So you can see it's currently totally empty. Let's play a 1 and a 1. And we need to fix our spacing a little bit there. Probably need a 1 space over. Let me play a 2-1. Okay, so I think our initial spacing, we need to space it over ever so slightly. So let's add one more space to the, let's see, colored row, 0, 1. So really, actually, everything should be, everything needs to take up 3 spaces, I think. So actually, let's make that 3 spaces there, because it's a space, the thing, and a space. Because before it was let's say a space, the number, and then a comma. So it should be 3 spaces. So let's say save that, come back out here, we run this again. It's a 3x3. Let's go 1, 1. Okay, now it's lined up right. And then let's run a, I don't know, 2, 1. And then let's go 1, 0. And then 2, 0. And then 1, 2. Congratulations, player 1 has won. But anyways, now we have beautiful, beautiful colors. Awesome. All right, and now for a few more Easter eggy type things. If we run Python, one thing is to import anti-gravity, and you get this nice little comic about basically what it's like to use the wonderful language that is Python. I'll let you read that in your free time. The other thing is, in Python, whenever there is a future change, maybe in a different language, and then we want to backport it to another language, we can do that. So the way to do that is from future, and then you import the thing from the future. And one of them that we can do is braces, and then we get kind of this goofy syntax error that just says not a chance. So I wouldn't expect braces to be in Python anytime soon. Okay, there is one last thing for me to show you, but I'm going to leave that for the end. And we are done. And I know you guys, you're still going to feel green. You're still going to feel new. That's normal. You're going to feel that way for years. So the best thing that you can do is get out there and start actually working on things that are exciting to you. When I learned Python, the thing I was trying to learn was to do sentiment analysis and natural language processing. Like, that's why I learned to program in the first place. And most people would have been like, oh, that's a horrible beginner project. But for me, it was perfect because it was what I was interested in actually doing. And so because I was excited about it, it made learning Python easy. And that's why I think basics are, it's important that we just get out of the basics as fast as possible. Is there a bunch of stuff that I did not cover that we would consider to be basic Python? Definitely. I mean, we left a lot of stuff, like even dictionaries, we just barely grazed them because I felt like it would be a sin not to show you dictionaries. But there's a lot of stuff that we didn't cover. And then some people have been asking about like object-oriented programming, stuff like that. If you go to pythonprogramming.net, click on the fundamentals here, and then go to the intermediate Python series. This series has a lot more concepts to it in terms of more advanced things. And then also object-oriented programming is done here. And we go quite a bit through that, including like doing special methods and all that kind of stuff. So if that's what you're looking for, it already exists. It doesn't need to be in this series. This series was really just to get you understanding Python and then get out and then like actually work on projects that are fun. If you want some ideas, come to the home page, click on stuff that interests you. You can also go to the Python subreddit, so reddit.com/r/Python. That'll take you to the recent goings-ons and happenings in Python right now, so you can get ideas on projects, see what other people are working on. There's also Learn Python is another one. So there's that. You can also come and join the Discord. Discord.gg/Centex will take you to an invite for the Centex server, and you can chat with a bunch of other people. And yeah, I mean, that's basically it. So just get out and start working on stuff that's exciting to you, and you're going to pick up and learn Python on the way. When you hit concepts you don't understand, Google it. When you hit an error you don't get, Google it. It's really simple to learn Python. It's just you got to stick with it and not get burnt out. And I think the best way to do that is to work on stuff that's exciting and interesting to you specifically. And that's not going to be found, I don't think, in a basics course. So anyways, I'm going to leave you guys with the last thing that you should import, and I'll let you read it on your own screen, but you can import this. And this will give you the Zen of Python by Tim Peters. And it's just kind of a good little thing to kind of live your life by when writing Python code. It's just something to continually remember and look at your script and see, am I violating these things? And it's just kind of a good thing to keep in mind as you code. So anyways, you can read that on your own. That's it. That's the end of this series. Quick shout out to the most recent sponsors, Suraj Deshmukh and Tharks Gamma. Sorry if I just totally butcher you guys' names. I apologize. As usual, if you don't know how to sponsor or become a member or whatever we want to call it, you can click that beautiful blue join button. That's it, guys. Get out of here.